Hey guys, a very good evening everyone. Welcome back to the special 26 series once again. Very good evening everyone. Welcome to the session, welcome to the class, welcome to the special 26. So I hope by this time you're all alert, you're all aware what this special 26 is going on. Yes, this is this is the special 26. Okay. 26 is the 26 topics, the most expected, important, frequently asked topics, okay, of electronics and electrical. So yes guys, very good evening. I am very good. How are you all guys? Quickly keep on joining the session. Yes, everybody quickly join the session quickly and let's get started then immediately. Yes. Okay ji. Okay. Fine, yeah, very good evening everyone. Good evening Anish, Ashish Kumar, Raj, Gir Babu, Kumar. Good evening Gate 24, Butterfly, Ankit Kumar. Good evening Gautam. Okay ji. So time to get moving ahead, time to get started then. Okay, so the special topic in this special 26 today, as you all must be aware how important Fourier transform is from signals and system. So let's do direct question point of view also, and indirectly multiple application based question also comes up from the Fourier transform. Okay, chalo, so let's get started. Fourier transform. This is a basic introduction. Okay, so Telegram link I'll share you later on. You will get the complete PDF in the Telegram. I know recently I have not got some PDFs, but I'll share you once I find time. Okay, chalo, great. Good evening Abhiram, thank you. So yes guys, UPSC engineering services results were declared some time back, and students, BYJU'S exam prep users have really outshined in the examination. Okay, 5 students under rank 10 with AIR 1, AIR 9, 29 under rank 50 and 37 under the rank 100. Yes guys. So now let's get started, and first let's have a quick review. Let's get moving ahead with the continuous time Fourier transform. Okay, let's focus the CTFT first. Okay, the continuous time Fourier transform, as you all know, see, I hope you are aware about the formula, but just a quick revision about the formula, the properties, important formula, and then let's get used to with the practice, what level of questions are expected. Okay, chalo ji, theek hai. Thank you Butterfly. So yes dear, the Fourier transform, okay, x omega, which is the Fourier transform of xt, is integral xt e power minus j omega t from minus infinity to infinity, and then the inverse Fourier transform is given by the formula xt is 1 upon 2 pi integral x omega e power j omega t d omega. We represent these always as the pairs, okay, x omega, the double-sided arrows, okay, something of this kind, or we also represent it like xt having the Fourier transform x omega, that is also double-sided arrow. Okay, meaning that if x omega has the Fourier transform, xt has the Fourier transform x omega has the inverse Fourier transform, that is known as the xt. So they are known as pair of each other. A ka Fourier transform b ka inverse Fourier transform a, something like that. Okay, now okay, you should always remember the convergence formula, okay, for the existence of Fourier transform, not deriving it, but yeah, you must know the conclusion. So let's have a quick revision. Hope this complete session gives you all properties, all insights about Fourier transform with the question practice. Okay, and little good question practice we will try to do, covering all important properties of the Fourier transform. Okay, the convergence condition is that the Fourier transform will converge if it satisfies the Dirichlet's condition. Okay, the first and the important mathematical result is a signal whose Fourier transform can exist must be absolutely integrable. Yes, if the signal is absolutely integrable, then only the Fourier transform will exist. That is, integral minus infinity say infinity mod xt dt should be finite. When you do the integration for absolute value of xt, modulus of xt, that result should be finite. Okay, also there are 2 other points which we write just to be sure that we are having a deterministic type of signal, not a random signal. So xt has a finite number of maxima and minima within any finite interval, and xt, if it has a discontinuities, it should have finite number of discontinuities within any finite interval, and each of the discontinuity is finite. Acha. Now first of all, before we talk about the properties, let's take a simple example. Okay, suppose I give you xt is equal to e power minus at ut. Okay, the exponential signal, the fundamental exponential signal, Acha ji. Okay, what is the Fourier transform? Now this is one formula, normally you study for the in the very beginning list of the formula, you should remember its Fourier transform directly, 1 upon a plus j omega. Okay. How do we calculate this? The x omega is, as I told you, basically given by the formula integral minus infinity to infinity xt e raised to the power minus j omega t dt. Xt e raised to the power minus j omega t dt. Now, because of the unit step coming into the picture, dear, because of the unit step coming into the picture, we know that ut is equal to 1 only for t equal to 0 to infinity. Otherwise, ut will be 0. Overall answer will be 0. So, because of ut, limits are changed, and then I have e power minus at e power minus j omega t. Combining the exponential, I can have e power minus of a plus j omega whole multiplied by t. Okay. Now, it's a simple integration of the form e power ax. Okay, so e power minus a plus j omega t divided by minus of a plus j omega from the limit 0 to the infinity. From the limit 0 to the infinity. Okay. From the limit 0 to infinity. Okay, now if I put down the value, okay, I'm going to get the upper limit e power minus infinity. Okay, lower limit e power minus 0 divided by minus of a plus j omega. Now, what is e power minus infinity is 0, e power 0 is 1 upon minus of a plus j omega. But dear, this is only existent if you ensure a positive. Dekho, the reason is, when you take the modulus of e power j omega t, when you take the modulus of e power j omega t, e power j theta modulus is always 1. Na? But if you take e power minus at modulus, and if a is suppose negative, if a itself you take negative, the minus minus plus, and then you put t tending to infinity. Okay, so it becomes the case of e power plus infinity, and the answer will not converge. The Fourier transform will not exist. Okay, so you have to ensure that a doesn't take up a negative sign here, otherwise negative negative, you will be going to the positive infinity for the upper limit. Okay, so you have to ensure that a is positive. Okay, so that you have e power minus of infinity, and that is tending to 0. Okay, that is tending to 0. Okay, so this one is the quicker formula that we can write down. Now, in the exam time, you don't have to derive this formula. I'm telling you, there is a list of Fourier transform formula that everybody must remember. Okay, I will tell you that list also. The list of Fourier transform formula that everybody must remember if you really want to score from this topic. Not every formula you can derive in the exam time. There are some important formula. Achha, not every formula to be remembered also, but there is a set of formula which is expected to be remembered, and I'll give you that list. Okay, so today's class, including the today's note, will summarize all Fourier transform important formula, will summarize all what? Okay, we'll also summarize all the properties of the Fourier transform. Okay, so that is what it is. E power minus at ut has the Fourier transform 1 upon j omega, but a should be the positive in that case. Acha, then there are some other important cases. Say for example, next important case if I want to talk here. Okay, just a second. So next important case, I hope everybody must be knowing its answer. So if I take xt is equal to delta t, what is the Fourier transform of impulse? Any type of transform of impulse is always 1. Na? Okay, okay. So x omega, that will be given by integral minus infinity to infinity delta t e power minus j omega t. And now you can use the property of impulse, that is integral ft delta t dt. Okay, integral ft delta t dt, okay, is given by f naught. Okay, so here the answer will be given by e power minus j omega t equal to t naught, f naught. So that is like e power 0, and that is equal to the 1. That is equal to the 1. Okay, ठीक है, ठीक है, चलो. That is what it is. So it is equal to 1. So impulse has the Fourier transform, the delta t has the Fourier transform, that is equal to the 1. That is equal to the 1. Okay. So Janendra Srivastava, we represent only periodic signals as sign decomposition. Na? Okay, I'm talking about a signal in general. I'm not talking about Fourier series right now. Fourier transform which is defined for aperiodic signals. Okay. Right. ठीक है जी. चलिए, so that is what it is. Delta t has the Fourier transform 1. So some fundamental formulas we will summarize. Acha, at the same time, look into this Fourier transform e power minus at ut. Okay, so I have a Fourier transform x omega, which is of course a complex function. Okay, and we can write down every complex function in the form of r e power j theta. Euler's form. We can write down the complex function as r e power j theta, that is known as the Euler's form. Okay, so what is the value of r then? Okay, what is this r then? Okay, the magnitude. Okay, the magnitude of x omega will be represented as modulus of x omega, and then theta we can write it as angle of x omega. Okay, angle of x omega. Okay, x omega we call it as the Fourier spectrum. Yes, Sai Krishna, will cover the duality questions also. Okay, so dear, what is the modulus of x omega here? What will be the magnitude? Magnitude of 1 is 1 divided by under root of a square plus omega square. Okay. What is angle x omega? What is the phase part? Numerator is 1, positive real number, phase 0. For denominator we write down minus. So minus a plus j omega, phase is tan inverse omega by a. Okay. Tan inverse omega by a. Okay, so x omega, which is known as the Fourier transform or Fourier spectra, okay, out of which the magnitude part we also call it as the magnitude spectrum, and this is what is known as the phase spectrum. We have the magnitude spectrum and the phase spectrum. Mod of x omega and the angle x omega. ठीक है जी, magnitude spectrum and the phase spectrum. चलिए जी, this is what it is. Okay, so now list of some important Fourier transform properties. Okay, so linearity, very basic. If two signals are added, so I have assumed two signals, x1t having the Fourier transform x1 omega, x2t having the Fourier transform x2 omega. Of course, having the Fourier transform x2 omega. If two signals are added, Fourier transforms are added. Basic linearity. If a signal is multiplied by a1, Fourier transform also multiplied by a1. Okay. Now time shift. We'll take up questions on this miscellaneous property, but let's complete the list. So time shift. Okay. Time shift corresponds to phase term in the frequency domain, exponential term in the frequency domain. So if I take x of t minus t naught, Fourier transform will become x omega e power minus j omega t naught. Okay, the Fourier transform is multiplied by the phase term, exponential term e power minus j omega t naught. Okay, time scaling. So x of at will have the Fourier transform 1 upon modulus of a, x of omega by a. Okay, that means if I want to, talk here, just let me elaborate this point here. So suppose if I take x2t, there are some fundamental, factual points also that you must remember. If I take, for example, x2t, so what will be the Fourier transform for x2t? 1 upon 2 x of omega by 2. Now, when you talk in terms of sketching x of 2t, so time scaling, what type of scaling it is? A greater than 1, so it is the case of compression. x2t represents the compression. But when you go to the frequency function, it is omega by 2. So in the frequency function, okay, the scaling is 1 by 2 actually. Okay, so that represents expansion. So just remember that if there is a compression in the time domain, there will be an expansion in the frequency domain and vice versa. Okay, vice versa. If the signal is compressed in time, its Fourier spectrum frequency will be expanded and vice versa. Okay, then similarly, if you put a equal to minus 1, in the same property, if you put a minus 1, so x minus t, time folding property, mirror image property will be x minus omega hai. Mod a to simply 1 rahega, correct hai na? So that will be x minus t having the Fourier transform x minus omega. ठीक है? Then duality xt, okay, having the Fourier transform 2 pi x minus omega. इसको थोड़ा सा अलग से समझ लेते हैं. Say for example, let's apply it here. E power minus at ut. What is the Fourier transform? E power minus at ut? 1 upon a plus j omega. What is the Fourier transform? E power minus at ut? 1 upon a plus j omega. Now apply the duality. Okay, in duality what we do? Okay, we replace omega by t. Okay, suppose if this was a time function, 1 upon a plus gt. 1 upon a plus gt. What is its Fourier transform? Okay, what is its Fourier transform? So I will replace omega equal to t, and if I replace omega equal to t, I get 1 upon a plus jt. So what is its Fourier transform? That is given by 2 pi 2 pi small x. Small x means the original time domain function, which is here e power minus at ut. So what you have to do is take up this e power minus at ut, okay, and then in this put down the value of t equal to minus omega. 2 pi x minus omega, t is replaced by minus omega, and then your answer will be what? Your answer will be e power minus at, t barabar minus omega, u of minus omega. So your answer is 2 pi e power plus a omega, actually u of minus omega. Okay, u of minus omega. And not only this, there will be multiple results that can be derived from the duality. We will take up that, okay, once we start with the questions. Acha, one more thing, one more important result can be seen from here. Impulse has the Fourier transform 1. Delta t has the Fourier transform 1. So what is the Fourier transform of 1 then? Apply the duality. Now the Fourier transform is constant 1, independent of omega. So even if you put omega equal to t, 1 remains to be 1. Na? 1 remains to be 1. That is the constant, and that is given by 2 pi x minus omega. 2 pi x minus omega, right? X minus omega. So yahan pe what will you do? Okay, you will replace t by minus omega, and that will become 2 pi delta minus omega. But we know that impulse is even symmetric function, so this becomes 2 pi del omega. Del minus omega is del omega because of even symmetry. And you have the next important result, 1. Okay, the constant 1. What is the Fourier transform for 1? It is 2 pi del omega. Okay, it is known as the 2 pi del omega. Clear? Okay. ठीक है क्या अंकित कुमार? ठीक है, so 1 has the Fourier transform 2 pi del omega. ये हो गया, ठीक है, done है जी. Okay, now next let's continue. So similarly you will be facing the differentiation property d by dt of xt Fourier transform j omega x omega if you differentiate n times. So j omega power n x omega. Coming to the integration property, integral minus infinity se t. This is t, integral minus infinity se t x tau d tau will have the Fourier transform x omega by j omega plus pi x0 del omega. ठीक है, यहाँ से unit step का निकाला जाता है. Okay, from here we calculate the Fourier transform of unit step. Okay, frequency differentiation t into xt. Okay, that is also not only frequency differentiation, this property is also known as t times property. Okay, multiplying any signal with t. If xt has the Fourier transform x omega, txt has the Fourier transform j d by d omega of x omega. Ultimately, frequency differentiation is being used. Okay, acha. So if I stop here, now have a look into it. Okay, we know again, coming back to the unit impulse again. We know the unit impulse has the Fourier transform 1. Now we also know the relation between step and the impulse signals. How can you represent unit step there? Okay, how can you represent unit step? The basics of signals. Integral minus infinity se t delta tau d tau, isn't it? This is integral minus infinity se t delta tau d tau. Okay, so what should be its Fourier transform then? Dear, what should be its Fourier transform then? Iska Fourier transform kya hoga? Okay, integral minus infinity se t x tau d tau, like the property. Which property? Integration property. That is given by x omega by j omega. So what is x omega? It is 1, constant 1. Okay, x omega by j omega plus pi x0 del omega. Now x omega constant 1 hai, so even if you put omega 0, okay, it's going to be 1 del omega. So what are these values I'm using? This is known as the x omega, this is known as the x of 0. Okay, so this answer is then equal to 1 by j omega plus pi del omega. This is the very, very important Fourier transform for unit step signal. 1 upon j omega, okay, unit step ut has the Fourier transform 1 upon j omega plus pi del omega, isn't it? 1 upon j omega plus pi del omega. Okay, now using frequency differentiation we write down one very important result. And what is that important result using the frequency differentiation? The important result using frequency differentiation is usko bhi dekh lete. So now again coming back to e power minus at ut, what is the Fourier transform? As discussed, 1 upon j omega for positive values of a, 1 upon a plus j omega for positive value of a, right? So what will be the answer for t e power minus at ut? T into xt, frequency differentiation, t into xt. So that is given by j d by d omega of x omega. So differentiate 1 upon a plus j omega, j d by d omega करना है, so that is going to be, now 1 upon x differentiation is minus 1 by x square. Okay, now with respect to omega we are differentiating, so by chain rule j will come outside. Now you have minus j square is again minus 1, so minus minus plus 1, 1 upon a plus j omega whole square. So your next pair t e power minus at ut, okay, having the Fourier transform 1 upon a plus j omega the whole square. ठीक है जी, okay, that is derived using t times property. चलिए next आ जाते हैं. Okay, now frequency shift. Okay, like time shift produces exponential term in the frequency domain, frequency shift will produce the exponential term, phase term in the time domain, but with opposite sign. If here you are doing omega minus omega naught, so it will be e power plus j omega naught t. Okay, so e power plus j omega naught t xt has the Fourier transform x omega minus omega naught. That has the Fourier transform x omega minus omega naught. Clear? ठीक है. Convolution x1t convolution x2t is x1 omega x2 omega. Okay, convolution in time corresponds to multiplication in frequency. Okay, convolution in time corresponds to multiplication in frequency. Okay, multiplication in time, okay, corresponds to convolution in frequency. 1 upon 2 pi x1 omega convolution with the x2 omega. अभी सभी पे question आएगा, don't worry. Okay, then modulation. If any signal is multiplied by cosine cos omega naught t, its spectrum is shifted to higher frequencies. Okay, x omega plus omega naught plus x omega minus omega naught whole divided by 2. Clear? That is given by x omega plus omega naught plus x omega minus omega naught whole divided by 2. Whole divided by 2. Correct? That is what it is. Okay, that is what it is. Done. Chalo. So we'll take up questions actually on these cases. Now very important, dear, very important, symmetry properties direct. Okay, it produces a lot of question. Okay, so if a signal is complex, okay, in general its Fourier transform will also be complex, but if a signal is real, the Fourier transform will be conjugate symmetric. If a signal is real, पहले इसको अलग से देख लेते हैं. Okay, so if a signal xt is a real signal, okay, the Fourier transform x omega is said to be conjugate symmetric. Okay, now what is this conjugate symmetric? Okay, the value of the Fourier transform for negative frequencies, okay, negative frequencies is given by the value of the Fourier transform for positive frequency just by taking the conjugate. X omega conjugate. X minus omega is x omega conjugate. I'm just feeling some cough. Gate 24. Yeah. Okay. So x minus omega is x conjugate omega. X minus omega is given by the x conjugate omega. Correct? That is what is conjugate symmetry. Now, if x omega is conjugate symmetric, two more points you must remember here. Okay. If x omega is conjugate symmetric, okay, let the x omega be written in the Euler form. Okay. Okay. Magnitude and phase spectrum. Magnitude and phase spectrum. Okay. Dear, if the Fourier transform is conjugate symmetric, let me tell you that magnitude spectrum will be even symmetric, and the phase spectrum angle x omega that will be odd symmetric. That will be odd symmetric. एक example देखेंगे यहाँ पे. Have a look into one of the example. Look into this one only. E power minus at ut, exponential real signal. Okay, exponential real signal. This is the e power minus at ut, the exponentially decaying right-sided real signal. Okay, now what is its Fourier transform? Now what is its Fourier transform, dear? 1 upon a plus j omega. In this x omega, take x minus omega. Take x minus omega. 1 upon a minus j omega. यही होगा ना, replace omega by minus omega. Now take x conjugate omega. Even if you take conjugate, one to real number है, no effect. But denominator x plus jy, conjugate of x plus jy is x minus jy. So that is a minus j omega. Okay, is it not the same? Is it not the same? This is what conjugate symmetry is. Clear? The Fourier transform for negative frequency x minus omega is equal to the conjugate of the positive result, conjugate of x omega. They are both the same because the signal was real. Now, moving forward, look into the modulus of x omega. Isn't it an even function of omega? Is it not the even function of omega? Yes. If you, it's omega square term. Now, even if you replace omega by minus omega, there is no effect on the square. So this one is even symmetric. Okay, this one is going to be even symmetric. Okay. Now, what about the angle x omega, dear? What about the angle x omega? Minus tan inverse omega by a. Okay, tan inverse x. What is tan inverse minus x? What is tan inverse minus theta? Minus tan inverse theta. Minus bahar aata hai na. So if you replace omega by minus omega, you are going to get minus of angle x omega. F minus x is minus fx. That is odd symmetry, na? That is odd symmetry. I hope you all know even and odd symmetry. Just orally मैं आपको बोलते जा रहा हूँ. So this is odd symmetric. So whenever a signal is real, Fourier transform is conjugate symmetric. Magnitude spectrum is even symmetric. Phase spectrum is odd symmetric. Okay, you must remember all these points because be ready. I'm telling you, from Fourier transform, good questions can also come. Okay, in the gate and aa chuka hai, aata rahega. Okay, the good conceptual property based question is done. Okay, so yeah, important about conjugate property is, okay, the magnitude spectrum will be even, phase spectrum will be odd. Achha, not only this, ab itna bola hai to ek aur point add kar deta hu. Okay. Now here I have written x omega in the Euler form. We can also write down x omega in the Cartesian form. Cartesian form means real plus imaginary part. So it can be splitted as xr plus jxi. Real part plus some imaginary part. Okay. Then if x omega is conjugate symmetric, as I have been telling you, for a real signal, x omega is conjugate symmetric. Its real part when you try will come up to be even symmetric again. Imaginary part will turn out to be odd symmetric. ठीक है जी? That also you must know. If you split into the Cartesian form, real part will be even symmetric. Okay, odd. The imaginary part will be the odd symmetric. Okay. Now next, this is about the signal being real. Fourier transform conjugate symmetric. If a signal is real and even, Fourier transform is real and even. If a signal is real and odd, Fourier transform will be pure imaginary and odd. And according to duality, if the signal is conjugate symmetric, the Fourier transform will be real. The Fourier transform will be real. That is according to the duality property, in consistency with the duality. Okay. Now, other than properties, there can be applications, that will be expected from this chapter, like area under the curve. Okay, applications like area under the curve. Okay, so if you talk about the area under the curve, see, this is the basic Fourier transform formula. Okay, but in this Fourier transform, when you take the DC value, okay, when you take omega equal to 0, okay, that is the x0 DC value. Okay, what do you get here? E power 0 is 1, you get integral xt dt. And here, what is the integral xt dt? The integral xt dt is known as the area of xt. The integral xt dt is known as the area of xt. Okay, so if you want to find the area of any signal which is mathematically complicated, okay, its Fourier transform can be used. Okay, the area is equal to the value of the Fourier transform at 0 frequency at DC term. Okay, okay, right. Similarly, sometimes, if you want integral x omega d omega, area under x omega, so as per the inverse Fourier transform property, it will become, okay, 2 pi x0. Okay, that will become 2 pi x0. Okay, 2 pi x0. ये यहाँ पे 1/2 pi miss हो गया. Okay, so in a sense, let me write it like this. Integral x omega d omega, area under x omega will be 2 pi x0. ठीक है जी? Okay, so this can be some application based question that can be coming up from here. Next application question can be coming up from Parsifal's question. सभी पे करेंगे, but idea is, as I told you in the beginning, let us revise the important terms. Okay, now Parsifal's theorem. Okay, definitely this is one good question producing area. Okay, good means difficult नहीं, but यहाँ से आते हैं question. Okay, हाँ, it can be made good if you combine those questions with energy spectral densities and the power spectral densities, right? So for any energy signal, we know this is the energy calculation of a signal in time domain. Area under the square of the signal, integral minus infinity say infinity mod of xt square dt. Integral minus infinity say infinity mod of xt square dt, and that is given by 1/2 pi integral minus infinity to infinity mod of x omega square d omega. Okay, that is what the Parsifal's theorem is. Okay, and for power signals, okay, if you want to talk about power signals, basically, okay, the power will be given by 1/time period. This is the time domain. Okay, there's a time domain result. Okay, in time domain we calculate the power 1/time period integral over 1 time period mod xt square dt. Okay, that is the power for periodic signals, and it is given by summation of mod ck square, where ck is the Fourier series coefficient. Okay, so for periodic signals we refer to the Fourier series to calculate the power. Right now for aperiodic signals we can use the Parseval's theorem, okay, to determine the power, to determine the energy, because again in time domain several integrations will be complicated to be dealt with. Also at the same time, let's have a quick review of important Fourier transform pair. Okay, some of them I discussed. See, each and every one of them is derivable. But since as a quick revision class of Fourier transform, we need not derive all of them. Some things, some important cases I've told you, but rest, let's have a look into the summary of all important Fourier transform pair formula and then go to the question. Okay, question देखेंगे किस तरीके से बन सकता है. So impulse has the Fourier transform 1. Okay, 1 has the Fourier transform 2 pi del omega. 1 has the Fourier transform, ये duality से देख लिया था हमने already. Then e power minus a t ut 1 upon a plus j omega, this is also already discussed. Then e power minus a mod t, note down, 2a upon a square plus omega square for a greater than 0 again. Otherwise the Dirichlet's condition will fail. Okay, t e power minus a t ut already I explained you with the differentiation, frequency differentiation property. It is given by 1 upon a plus j omega whole square, again for positive a. This is also discussed with integration property. Unit step, Fourier transform 1 by j omega plus pi del omega. Signum function has the Fourier transform 2 by j omega. भाई signum का कैसे निकालते हैं? How do you calculate for signum? Okay, remember the relation between the signum function and the step function. Signum function is actually given by 2 ut minus 1. Okay, signum function and the step function relation 2 ut minus 1. That is why when you want to calculate its Fourier transform, it is twice of unit step Fourier transform. That is 1 by j omega plus pi del omega. Fourier transform of step, you know, na, 1 upon j omega plus pi j omega minus Fourier transform both the sides. So what is the Fourier transform of 1? Don't write 1, na. Fourier transform of 1 is 2 pi del omega. Okay, now when you open it, na, you get 2 by j omega, because now you have 2 pi del omega minus 2 pi del omega cancelled. ठीक है जी? Yeah, for u minus t, just reverse the omega. Okay, so you'll get 1 upon minus 1 by j omega plus pi del omega. This will remain to be del omega, Ankit, because of even symmetry in impulse. Chaliye, so what it is? 2 by j omega is the Fourier transform for signum. Okay, now e power j omega naught t. E power j omega naught t. Okay, 2 pi del omega minus omega naught. Okay, 2 pi del omega minus omega naught. This can be derived using frequency differentiation. You apply the frequency differentiation to this result. That is 1. Okay, you will get the answer. Next, okay, cos omega naught t has the Fourier transform. Now, once you know for e power j omega naught t, you can derive for sinusoids, na? Sin theta and cos theta both. Okay, so using this e power j omega naught t, then we get cos omega naught t Fourier transform pi del omega minus omega naught plus del omega plus omega naught. It only contains two impulses at the fundamental frequencies, at omega naught and minus omega naught, and the area of the impulse is equal to pi. For sin omega naught, it turns out to be pi by j del omega minus omega naught minus del omega plus omega naught. Now, next very important case is the rect. Now, lots of questions you can expect based on the rect signal. Lots of questions you can expect based on the rect signal only. Rect t by t. Rect t by t has the Fourier transform t sampling omega t by 2. T sampling omega t by 2. Now, when I want to talk about the rect signal, see, there's a standard way of writing the rect. Let me explain you the rect signal to you. Okay, so when I write rect t by t, please, you can note down this. When I write rect t by t, okay, when I write down rect t by t, okay, it's a rectangle having the total width of t. It should be a rectangle having the total width of t, and we draw it as a symmetric rectangle, means centered at origin. So hence it will be located from the minus t by 2 say plus t by 2 point. Total width will be equal to t. Okay, amplitude 1. Okay. Acha ji. If you want to define tri, okay, note down both. Whenever we write tri t by t, what does it mean? So tri t by t is a triangular function, symmetric triangular function centered at origin, having the total width of 2t. Having the total width of 2t. Okay, that means this triangle will start from minus t and go up to the t. Centered at origin, it is symmetric case. Maximum amplitude is 1. If I tell you 2 try, the amplitude will also become 2 correspondingly. Right now, let's take it as 1. Height is 1. Okay. And the total width is 2t. And that is why it is located from the minus t to plus t. It is located from minus t up to the plus t. ठीक है जी. From the minus t up to the plus t. This is done. From the minus t up to the plus t. ठीक है. चलो next. Okay, so you must remember these basic definitions of rect and tri. Now, rect t by t Fourier transform t sampling omega t by 2. Okay, when I say sampling, see, when I say sampling x, yeah, sampling theta. What is sampling theta? Sampling theta is written as sine theta by theta. Okay, there is another representation in terms of sinc. What is sinc theta? Sinc theta is known as sine pi theta upon pi theta. Okay, so what is the relation between sinc and sampling? What is the relation between sinc and sampling? You can write down na sinc theta. Okay, sine pi theta by pi theta. तो यहाँ पे अगर pi pi लिखा, so that should come here also. Okay, तो sine pi theta upon pi theta should be equal to sampling pi theta actually, correct? Should be equal to the sampling pi theta. Okay, so sinc theta is sampling pi theta. Okay, so that is why this formula can also be written as T sinc. Now I want to convert sampling to the sinc. I want to convert the sampling to the sinc. So divide by pi here. Divide by pi here. So this becomes how much? Omega t upon 2 pi divided by pi. कितना हो गया? T sinc omega t by 2 pi. If you want to write down in the form of sinc. Okay, remember in any one, yaar. Sampling or sinc. They are convertible. Acha, also, then this is also equivalent to, this is also equivalent to T sinc. We know that omega upon 2 pi will be f, na? Omega upon 2 pi will be f. So you can also write it as ft. T sinc ft. T sinc ft. Okay. Now triangle is obtained by rect convolution rect, if you remember the LTI system fundamentals. Okay. Rect, convolution, rect of equal duration. Whenever two rectangles of equal duration are convoluted, you get a triangle. So triangle is obtained by rect, convolution, rect, and whenever there is the convolution in time, there is the multiplication in frequency. Solving it up, derivations as I told you not required right now. Solving up, you get T sampling square omega t by 2. The Fourier transform of triangle is in the terms of sampling square. Now, if rect has the Fourier transform sampling, exact formula T sampling omega t by 2, but nature की बात करते हैं, rect Fourier transform sampling. So, as per the duality logic, what should be the Fourier transform of sampling? It should be like rect, na? The dimensions and of rect and all we will write, but it should be rect nature. Na? Nature की बात करेंगे. If rect has the Fourier transform sampling, sampling should have the Fourier transform rect. You can note down the exact formula derived by the duality. We can do it within a second by duality, but write down the final result right now. Sampling 80, Fourier transform pi by a rect omega by 2a. Very, very important. Okay. Sampling square 80, Fourier transform pi by a tri omega by 2a. ठीक है. Gaussian pulse. Okay, e power minus 80 square. Okay, that is Gaussian. The Fourier transform of Gaussian is Gaussian. Okay, so e power minus 80 square has the Fourier transform root over pi by a e power minus omega square by 4a. Okay, the Fourier transform of Gaussian is a Gaussian. Okay, ठीक है. तो try sampling all this is seen. Okay, sampling square. Okay, Gaussian भी देख लिया हमने. Okay, root over pi by e power minus omega square by 4a. ठीक है. अच्छा, one more discussion from here. Signum t has the Fourier transform 2 by j omega. We got this answer from the unit step, right? So now I can write down, have a look into this discussion again. Signum t has the Fourier transform dear how much? 2 by j omega as we derived from the unit step concept. Okay. Now apply the duality. So 2 upon jt, omega will be replaced by t. Okay, so 2 upon jt, what is the Fourier transform? Okay, 2 pi signum minus omega. Okay, t will be replaced by minus omega. So as per duality, okay, I put omega equal to t and then the Fourier transform is obtained, okay, in the original function by putting t equal to minus omega. Acha, what is signum minus omega, dear? What is signum minus omega? Okay, what is the signum waveform? Okay, what is the signum waveform? अगर ओमेगा के रिस्पेक्ट में देखें, we know that signum value is 1 for right hand side, it is -1 for the left hand side. Clearly the value of the right and left, okay, are equal in magnitude but opposite in sign. They are identical but they differ in sign. It's like odd symmetry. Signum shows odd symmetry. Signum minus omega is minus signum omega. So that means this this is going to come 2 pi minus signum omega. Okay, and hence this is equal to minus 2 pi signum omega. Hence this is equal to the minus 2 pi signum omega. ठीक है dear? Minus 2 pi signum omega. Okay, so 2 से 2 cancel करते हैं. Okay, so I have dear, let's continue. 2 upon jt, what is the Fourier transform? Minus 2 pi signum omega. Minus 2 pi signum omega. 2 से 2 cancel कीजिए. ठीक है? Right. 2 से 2 cancel कीजिए. Shift the j on the right side. Okay, you get 1 upon pi. Bring the pi on the left side. 1 upon pi t has the Fourier transform. Minus j signum omega. 1 upon pi t has the Fourier transform minus j signum omega. Now this result is related to what? This result is related to anybody? Anybody? Very, very important point here. This result is related to what? What concept? What system? What function? Okay, minus j signum omega. Minus j signum omega, pi by 2 phase shifter. Right, what is minus j? Okay, j can be written as e power j pi by 2. Okay, I have minus j, so e power minus j pi by 2. Minus j can be written as e power minus j pi by 2. And when you want to plot this, Fourier transform h omega, let us say this Fourier transform is h omega. Let us say this Fourier transform is h omega, and then this is the time domain signal ht. Okay, so h omega minus j signum omega. Okay, so minus j is e power minus j pi by 2. That is just a phase term. Okay, that is just a phase term. Okay, and signum omega is 1 for right hand side. The right hand side phase will be minus pi by 2. I mean, I can just write it in terms of phase. Okay, if you want to write down in terms of phase, angle h omega. Yeah, if you want to draw it up with h omega only. So what is there on the right side? Okay, minus j. Okay, and left side minus j into minus 1, that will become plus j. Right side minus j, na? Sorry. And left side it will be plus j. Now, if you mathematically see, plus j will be pi by 2, minus j will be corresponding to the phase of minus pi by 2. Minus j phase is minus pi by 2. Plus j it will become plus pi by 2. Pi by 2 phase shifter. Okay, and this is the frequency response h omega of Hilbert transformer. The pi by 2 phase shifter. This is Hilbert transformer. Okay, Hilbert transformer. ठीक है जी? चलो. So 1 upon pi t has the Fourier transform minus j signum omega. Okay, minus j signum omega. ठीक है, चलो डन है. Okay, now let's move ahead. Yeah, so I think all important formulas and pairs discussed. Okay, so now before I take the question, let's practice some miscellaneous questions also. But before I take up that, a quick reminder, guys. The Sunday, that is just day after tomorrow, 10th December. Okay, you can appear in the upcoming BYJU'S National Scholarship Test. Based on the performance in the National Scholarship Test, you can get as much as up to 90% discount on the GATE preparation courses. Okay, and then you can take a next step towards your success in the GATE examination. And also, if you're looking for the guidance for GATE 2025, if you're preparing for GATE along with college or along with job and confused, okay, how can you manage time? You may be not able to manage time with college or job, but let me tell you, many aspirants do it actually with college time only. Most of the toppers have done it with college time only. Okay, so what is a time management fund? How to manage GATE preparation along with college and job? How people do it? Okay, a free live, very interactive workshop on the BYJU'S exam prep app, and that's to be taken by me only 13th of December, Wednesday. Okay, 7:30 p.m. Join me live. ठीक है जी, 7:30 PM. चलो, yeah, now let's come to a question. Okay, starting with multiple select. A multiple select MSQ question. Come on everybody. Right. Okay, क्या बोला है? Let xt be x omega be the Fourier transform pair, then the Fourier transform of the differentiated signal. अच्छा, okay. What happens to the Fourier transform of differentiated signal? Fundamental question, guys. Based on property directly, xt having the Fourier transform x omega, d by dt of xt has the Fourier transform j omega x omega. Now क्या बोल रहे हैं? Okay, magnitude spectrum is scaled. Okay, अच्छा, magnitude spectrum originally it is x omega. Okay, now it is multiplied by omega. मतलब अगर आप इसका मॉडुलस लेना चाहोगे ना, when you take mod of j omega x omega, modulus of j is 1, so it is omega x omega, and omega is 2 pi f. So magnitude is multiplied by 2 pi f. Okay, that is correct. It is scaled by 2 pi f. Okay, phase spectrum. Okay, now what is this j? As I just explained you, this j is e power j pi by 2. It brings up a phase of pi by 2. It brings up a phase of pi by 2. ठीक है? तो yes, this can be written as magnitude part omega x omega e power j pi by 2. J can be written as e power j pi by 2. The magnitude is scaled by omega, that is 2 pi f, and phase, okay, is shifted by pi by 2. Okay, so क्या बोला है? Phase spectrum adds by 90 degree, positive 90 degree. So correct answer for the multiple select question is A and C. It is the A and C, everybody. Clear? It is the A and C. ठीक है जी, next question. Right. Choose the correct statement regarding the CTFT of the two functions f1 and f2. Okay, अच्छा. Again, this is a MSQ question only, dear. ठीक है? MSQ question. Thank you, me. Thank you. Chalo, dear, tell me. It is a very simple property based question actually. What is f1t? Okay, real and even. Okay, it's definitely all the values are real. It's a real axis only, and even. It is even symmetric. Mirror image, right and left are identical, mirror image of each other. But what about f2t signal? Okay, the signal is real but odd. The signal on the right and left, okay, they are identical. I mean, if you take the mirror image of the right to the left, this is the mirror image. Sorry. This is going to be the mirror image. Okay, so mirror image and the actual signal, they just only differ in the sign. That is odd symmetry. Okay, so if a signal is real and even, Fourier transform is also real and even. So option number A correct. Fourier transform of f1t is real and even. But for the f2t, Fourier transform should be pure imaginary and odd. Okay, for f2t, pure imaginary and odd. It is A and D. Okay, so like this. Okay, like this. You know, what we can say is MSQ questions can also be framed like previous one and this one. A and D, not A and B. No, B. देखो, F2T is real and odd. They're asking about CTFT of FF2T. So B is not correct. Some of you are telling B. Be careful. Okay. ठीक है. ठीक है. Yes, Nani, that's what. And that is why I started with the basic revision. I did not start with the question. Okay, so that, you come to a position of handling different variety of questions once you have all the properties, important concepts in mind, and then we are starting with the questions also. Okay, so done it here? Yes? Next question then. For which of the following signal imaginary part of the Fourier transform would be 0? Imaginary part of the Fourier transform would be 0. By imaginary part 0, that means imaginary part nahi hai. That simply means they want the Fourier transform to be purely real. Okay. Fourier transform to be purely real, and that is possible if the signal is real and even. Okay, if the signal is real and even, xt must be real and even symmetric. Then only the Fourier transform is real and even. Fourier transform real hona chahiye, that is required. It will be also in addition even. Okay, that is extra. Okay, so which of the option is even symmetric now? Okay, this is not symmetric, this is odd symmetric, this is odd symmetric. Option number D is even symmetric. Option number D. Yes, correct answer. Gate, Nani, Meghna, Ankit Kumar. Yeah, that is the correct answer. Option number D. Option number D. Yes, Akansha, correct answer. Next question, dear. All right. Now, a property based. Fourier transform for e power minus of t minus 5 u of t minus 1. E power minus of t minus 5. Now, what is the Fourier transform? We know e power minus 80 ut यहाँ पे use करेंगे. E power minus 80 ut with a equal to 1. With a equal to 1. Okay. So, what should be the Fourier transform for e power minus t ut? Forget the time shifting. Definitely the question is taking you towards time shifting, but for a moment forget the time shifting here. ठीक है. What is the Fourier transform for e power minus t ut, dear? ये बता दीजिए. Fourier transform for e power minus t ut. It is given by 1 upon a plus j omega. That is 1 upon 1 plus j omega. That is a 1 upon 1 plus j omega. ठीक है? 1 upon 1 plus j omega. Now, I want to apply the time shift. But the time shifts is in unequal measure. Unequal measure. Right? E power minus t minus 5 u t minus 1. Try to manipulate according to the unit step. तो अब given signal को ले लेते हैं. Given signal is e power minus of t minus 5 u of t minus 1. Okay, u of t minus 1. अब बताइए. Okay, if whatever is the time shifting inside unit step, now try to manage with that. Okay, so t minus 5 I will write down minus 1 minus 4. Okay, split it like this. Okay, now it is going to be e power minus of t minus 1 minus of minus plus 4, and e power 4 is a constant. Write it here separately. E power 4 into e power minus t minus 1 into u of t minus 1. Now can I write down the answer? If this is xt, what is the Fourier transform? Dekho dear, e power 4 is constant. Constant appears both the way. If signal is multiplied by a, Fourier transform also multiplied by a. Okay. Then we know the Fourier transform for e power minus t ut. Write down that answer first. 1 upon 1 plus j omega. But I have t minus 1. I have the right shifting. Time shifting corresponds to exponential term, phase term. So in the frequency domain, there will be a phase term e power minus j omega t naught. How much is the time shift? 1 unit. So e power minus j omega into 1. Okay, it is minus 1. So यहाँ पे भी minus j omega आएगा. Signs are same. Okay, so the final answer is combining the exponential also, e power 4 minus j omega. E power 4 minus j omega divide by 1 plus j omega. Let us go and match the option now. Let us go and match the option now. E power 4 minus j omega divided by 1 plus j omega. Option number C. Perfect. Option number C. ठीक है जी. Yes, correct. Ankit Kumar, Akansha, Gate 24. Correct answer. It's C. It's option number C. Be ready for the next question. Here it is. Let xt be x omega be the Fourier transform pair. What is the Fourier transform of minus 2x minus 70 plus 3 in terms of x omega? Please try this. Purely properties here. It is just purely properties that you have to apply and get me the answer. Okay. It is just purely properties. Yes, do it up. Do it up, do it up, do it up. It will go. Let's practice some more question. Maybe at least 30 more minutes around. Questions करेंगे अभी हम. Because question is the whole that you have to get in the Fourier transform. चलो. Yeah, hope so you have done something. Let's match. C, A, B, A. I'm getting variety of options. So let's check it out, guys. carefully. Okay, xt has the Fourier transform given to me. That is x omega. Now dear, suppose you wanted to sketch x of minus 70 plus 3. What will you do first? Shift or scale? You can do anything actually. But what you normally prefer? Suppose you wanted to sketch the signal x of minus 70 plus 3 where scaling and shifting both occurs. You can do either of the case first. But preference rules. Okay. The preference says that choose shifting first, so that you don't commit any error. So we call it as a precedence rule. Okay, you can do both. Mathematically, graphically, both are 110% okay. Okay, but shift pehle karoge, so you are always safe. You don't commit error. Okay, you don't commit error. Okay, the same precedence rule you apply here. Same precedence rule you apply here. So first, let us talk about the shifting. Okay, same thing. X of t plus 3. How much is the shifting? Plus 3. When you are shifting, forget this coefficient of t. Okay, forget this. Okay, the x of t plus 3. So that is time shift property. Exponential term, phase term, x omega e power plus j3 omega. E power plus j3 omega. Yahan plus 3 hai, so here also plus 3 omega. Okay? Now go for the x of 70 plus 3, one by one. Okay, now I am scaling. Scaling and folding you can apply simultaneously, but yeah, let's do it one by one carefully. So x of 70, like x of 80 property, so sabse pehle 1 upon mod a. First thing is 1 upon mod a, so that is 7. X of omega by 7. Okay, here also. Now this is complete frequency function. So every omega should be replaced by omega by 7. So x omega by 7, e power j 3 omega by 7. ठीक है, e power j 3 omega by 7. Okay, now replace t by minus t. So x of minus 70 plus 3. Okay. Okay, so time reversal, frequency reversal. So every omega will become minus omega. So x minus omega by 7, e power minus j3 omega by 7. Last but not the least, minus 2 is just a constant number. If it is multiplied in time, it is also multiplied in frequency. So I can write this as now minus 2, x of minus 70 plus 3. Okay, same number minus 2 to be multiplied here also. So minus 2 by 7, x of minus omega by 7, e power minus j3 omega by 7. Start checking your answers. Okay, so minus 2 by 7, x of minus omega by 7, e power minus j3 omega by 7. Option number B. Perfect. Yes, it is the option number B. ठीक है जी? B is correct. Okay, so correct Kumar, Gajendra, Akansha, Meghna, Ankit Kumar, Nani. Correct answer. B will be the absolute correct answer. B will be absolutely correct. Okay, no doubt. Next question then. The Fourier transform of the signal t e power minus 3 mod t minus 1. Okay, take this question. Take this question, dear. The Fourier transform of the signal t e power minus 3 mod t minus 1. The Fourier transform of the signal. So देखो, how we are going to break here. We know about e power minus a mod t. What we are going to use? Recall e power minus a mod t Fourier transform. What it is? 2a upon a square plus omega square, but a should be positive. Okay. So here, let's start with e power minus 3 mod t and then think about shifting. But again, shifting is here t minus 1. It is not here. So I will first try to manipulate the signal. थोड़ा सा इसको manipulate करेंगे. And the signal is of the form xt is t e power minus 3 modulus t minus 1. Okay, let's try to break it. Okay, here it is t minus 1. So inside also let me try to bring t minus 1 and then plus 1 to nullify the effect. And now split it up. This becomes t minus 1 e raised to the power minus mod e power minus 3 mod t minus 1 plus e power minus 3 mod t minus 1. Okay, if this is the xt dear, what is going to be the Fourier transform? Let's do some separate calculations here. Let me start with dear. What can I do? Let me start with e power minus 3 mod t. e power minus 3 mod t. Okay, so what is the Fourier transform? As per the formula 2a upon a square plus omega square, so 2 3s are 6 upon 3 square 9 plus omega square. That is the formula. Now, in one of the term, I need e power minus 3 mod t minus 1. That is simple time shifting. And here I want t minus 1, time shifting and t also multiplied. तो पहले एक काम करेंगे, multiply by t. Multiply by t. T times property. T times property will take you towards frequency differentiation. T times property will take you towards frequency differentiation. So 1 upon x का differentiation. Okay, first of all, sorry, what happened? 1 upon x का differentiation minus 1 by x square. तो minus 6 by 9 plus omega square का whole square multiplied by chain rule multiplied by 2 omega. ठीक है? Okay. So this one is minus 12 omega upon 9 plus omega square whole square. ठीक है जी? This is the case. अच्छा. Now next. Okay. Now next. I will apply the time shifting. Now I will apply the time shifting. Okay. So I'll write down the answer here. Okay. I'll write down the answer here. Directly time shifting apply करके लिखते जाते हैं. तो first one is minus 12 omega upon 9 plus omega square whole square. This is for t e power minus 3 mod t. But now t minus 1, you know exponential term will be multiplied to e power minus j omega. How much? Minus j omega, because time shifting is only t minus 1. It is only t minus 1. Similarly, next, e power minus 3 mod t. Okay, then time shifting. So first write down the result, 6 upon 9 plus omega square, then apply the time shifting e power minus j omega, match the options now. Okay. तो definitely ये 6 वाला term तो आएगा. Only option number A guys. 6 वाला positive में है. हाँ, both are positive. This was negative. Correct है. 6 e power minus j omega upon 9 plus omega square. Second check करेंगे. Minus 12 j omega. अच्छा, sorry, हाँ, that is j omega. Correct. E power minus j omega upon 9 plus omega square whole square. This is absolutely correct. Option number A. Okay, yes, gate 24 and Ashish Kumar, correct. It is option number A. Perfect. Okay, ये J यहाँ पे आएगा ना. The frequency differentiation property J d by d omega. Okay, J d by d omega, and that is a differentiation written. Okay, so let me multiply that J here also. I just missed that, but that's okay. Okay, Ji. So this one is a good combination of properties, mind it. This question can be a good property based question. Next, which of the below Fourier transform pairs are correct? MSQ question. Which of the below Fourier transform pairs are correct? Now some can be direct and some you can try to answer. Okay, unit step as the Fourier transform 1 upon j omega plus pi del omega. जो direct पता है उसको बताइए पहले. Some of the things you know directly. This is D correct. Okay, cos omega naught t या omega 1t, pi del omega minus omega naught plus del omega plus omega naught. C is also correct. 1 upon pi t. 1 upon pi t. Fourier transform for 1 upon pi t? Wrong. This should be minus j signum omega. This should be minus j signum omega. 1 upon pi t Hilbert transformer. 1 upon pi t Hilbert transformer है, ठीक है? So minus j signum omega. We have seen that today, na? Okay. Now next, minus 1 by pi t square. How to get minus 1 by pi t square? C and D correct है, B not correct. What about A? MSQ है ना, तो any number of options can be correct. देखो, how can you get minus 1 by t square if you are given 1 by t? Let's solve this. Only this is the thing that you have to solve. Rest are standard results. Okay. 1 upon pi t. Fourier transform minus j signum omega. Okay. Now, time differentiation. Because when you differentiate 1 upon t, the derivative of 1 by t is minus 1 by t square. Okay, so time derivative property says that the Fourier transform is multiplied by j omega x omega. So j omega into minus j signum omega. Now 1 upon t ka differentiation minus 1 by t square. So you get minus 1 by pi t square. Okay, j square is minus 1, so minus minus plus. Okay, plus omega signum omega. Now they have given in the form of mod of omega. Is that correct? ये भी देखते हैं. Plus omega signum omega. Now we can write this as, so dear, if omega is greater than 0, if omega is greater than 0. Signum omega is 1. Okay, the answer is omega into 1, that is omega. But if the omega is negative, if omega less than 0, what is the value of signum omega? Minus 1. So omega into minus 1 will be minus omega. Okay, so what is this? Okay, what is this? This is like the modulus value. Okay, if a number is, see, how do you say what is the modulus of 5? It is 5. But when you want to take modulus of minus 5, we can write it as minus of minus 5, so that you get 5. So whenever omega is negative, I place minus in front, so that minus plus. If omega is positive, I write an omega. That is what is the modulus function definition also. Mathematics को याद कीजिए, what is mod x definition? So this is nothing but mod omega. So correct option है, right? नहीं. Negative was there, but j square also will bring the negative net here. J square is minus 1, so minus eventually plus. Okay, gate. Okay, so mod omega is the correct thing. So A option is also correct. A option is also correct. Okay, ji. A option is also absolutely correct. MSQ question A, C, D. The three options, that is the A, C, D are correct here. चलिए आ जाते हैं next. Consider the signal xt equal to 1 for mod t less than 1. Find the Fourier transform of xt. Very simple. This is a simple one. ये एक simple है, but अब इस पे link करेंगे question को. Now, what is the meaning of mod t less than 1? Magnitude of modulus of t less than 1. So t, of course, can be between 0 to 1, or it can be between 0 to minus 1 also. When you take 0 to minus 1, then also magnitude is less than 1. So actual range of t is minus 1, 7. Any value between minus 1, 7, you take mod, it is less than 1. Okay, so when you sketch this, as I am telling you, this one is simple. इसमें कोई complication नहीं है. This one is simple. Okay, but now we are going to link questions with it. We are going to have the questions linked with it. Okay, so xt equal to 1, mod t less than 1. Xt equal to 1 whenever t is between the minus 1 to the plus 1. What is this waveform, dear? Okay, this is the rect waveform. Rect of t by, now you should know, rect of t by how much? T upon width. Total width is 2. Minus 1, 7 है, total width is 2. We write down rect t by 2. Rect t by t, capital T, is the total width of the rectangle. Okay. Now what is the Fourier transform? Just a small recollection. Very, very important formula to be recalled, and then we move to towards the miscellaneous questions based on that. Rect t by t, having the Fourier transform t sampling omega t by 2. Correct. So if rect of t by 2 is given to me, so that will have how much Fourier transform? 2 sampling t की जगह 2 रखा तो 2 sampling omega. Options are in the form of sine, no problem. Okay, so we know the definition of sampling omega. It is sine omega by omega. So answer should be 2 sine omega by omega. Answer is 2 sine omega by omega. That is option number C. That is the option number C. That is what is known as the option number C. Okay ji, बढ़िया है. Next question. Next question, here it is. A signal is represented by xt equal to 1 mod t less than 1 and 0 for mod t greater than 1. Okay, that is again, like I already explained you, this is the rect of t by 2. Okay, so there can be multiple questions on rect t by 2. Be ready for it. Okay, now what is the Fourier transform of the convolved signal x2t convolution xt by 2? देखो, if you try to convolute, first of all, the signal xt is rect. This is compression. Okay, compressed rect. This is expansion, expanded rect. So there will be two rectangles of unequal duration because one is compressed, one is expanded. Two rectangles of unequal duration, एक बड़ा है एक छोटा है. Two rectangles of unequal duration, if they are convoluted, the result is trapezium. You get a trapezoid signal. Then you start calculating Fourier transform. Oh my god, that's so lengthy. Oh my god, that's so lengthy, na? How can you make it simple? Properties. Okay. Property is always your tool to make it simple. Property is always your tool to make it simple. तो चलो कैसे करेंगे simple आ जाते हैं. Okay, so I have xt is rect t by 2. Okay, so first let me write down the Fourier transform of xt itself. Xt is rect t by 2. So what is the Fourier transform? T sampling t sampling omega t by 2. Okay, so this is 2 sampling omega, just like the last question answer. Okay, now let's move forward. Okay, now you are given yt. Now you are given yt x of 2t convolution with xt by 2. Whenever there is convolution in time, there is multiplication in frequency number 1 and also 2t compression. Time scaling is there. So we can apply scaling and convolution property ka mixture. Okay, so what is going to be y omega? Okay, first of all, write down in terms of x. x2t Fourier transform. Time scaling 1 by 2 x omega by 2 1 by mod a x omega by a. Okay, what is the Fourier transform for xt by 2? 1 upon half 1 upon a x of omega by a. Okay, x of omega by a. Now convolution in time, so there will be multiplication in frequency. So now when you are multiplying, what is the result you are getting? This is 1 by half. This will become 2, so that is cancelled. So you are only left with, I can say, x of omega by 2 multiplied by x omega by half. Please write it as x2 omega. Please write it as x2 omega. ठीक है, x omega by 2 x2 omega. Okay ji, chalo, so let's see the result then. X omega by 2 or x2 omega. Okay, so now we know the value of x omega, na? We know the value of x omega. So write down the answer. So this is going to become, okay, x omega by 2. So 2 sampling omega by 2. Next is 2 sampling omega ki jagah 2 omega. So 2 sampling 2 omega. Just use this result. Now answer, okay, 2 2s are 4. Options are in the form of sine. Okay, so sampling omega by 2, sine omega by 2, okay, upon omega by 2. Sampling 2 omega is known as sine 2 omega upon 2 omega. So further 2 denominator cancelled. Final answer should be, let's just match the answer, 4 sine omega by 2 sine 2 omega by omega square. My answer is option number A. 4 sine omega by 2 sine 2 omega divided by the omega square. Done hai? Option number A, correct answer. Option number A, very correct answer. Next question. Yes. Consider the signal xt equal to 1 mod t less than 1. Once again, what is the signal given to you? Same, rect t by 2. So making different varieties of question on rectangle. I told you in the very beginning, rectangle is very, very important. Sometimes they ask direct also, 1 marker, but usually they mix up with some concept and property, like previous one was convolution plus scaling. What is this? Given a signal, find the Fourier transform of the signal. So there is a hint also. Okay, what is the Fourier transform yt, and somehow rectangle is given. So can we manipulate yt and write down in terms of xt? Can we try something of that kind? Can we try something of that kind? Yeah, let me know. Can we try something of that kind? Look into the waveform carefully and let me know if we can try something of that kind. Okay ji. Chalo, so let's do it. Let's do it. How you can do it? Dekho, what is the xt? What is the xt? Let me draw the xt first. Okay, let me draw the xt first. That is a rectangle signal. That is what? A rectangle signal from -1 to 1. Okay, what you are given, now look into this. Yt is a straight line from -1 to 1. What is the straight line? mx plus c or mt plus c. The x-axis is t-axis here. mt plus c. What is the value of mt? What is the value of c? C is 0. Y-intercept, it is passing through origin. Slope, okay, height 1 unit, base 1 unit, so slope will be 1. The slope is 1 unit. Okay, so this is simply equal to t. Yt equal to t. Okay, what is this? Yt is equal to t. Okay dear, so this value is known as the yt equal to t. ये भी ठीक है. Now next, okay, yt equal to t, ये भी clear हो गया. What is next then? Okay, so yt is t, but only from, I can write down what is yt. Yt is equal to t only between -1 less than t less than 1. Okay, चलो let's make it more simple now. Okay, let's write it in the functional form only. थोड़ा और simply बता देता हूँ इसको. Okay, what is the yt? Yt, we have got the straight line t, but that is only from -1 to 1, otherwise it is 0. Okay, yt equal to t, -1 less than t less than 1. I can write it as t into 1 -1 less than t less than 1. Yt is equal to t into 1 -1 less than t less than 1. How much is this portion? What is this, dear? What is this? Forget the t. 1 -1 less than t less than 1. That is the xt. That is the rect signal. Only thing is, okay, this definition is the rect definition. So I can say that yt signal is nothing but t times the rect signal. And t times property, frequency differentiation property. So this question using the rectangle signal is on the frequency differentiation property. Frequency differentiation property. ठीक है? Frequency differentiation property. No gate 24. No. If you integrate, okay, after t equal to 1, result will be something else. Okay, after t equal to 1, up to t equal to 1, your integration will match, but after t equal to 1, the entire area, integration is area, that will be flat 2. Okay, जो आप बोल रहे हो ना gate 24, okay, this is that question, and I'll give you this question as homework, guys. Lot of question on xt only. So there is one question as homework also, and hint is already there, integration. Try the integration property. Okay, this one will be homework. Try the integration of rect. Okay, when you try to integrate rect, this is the waveform you will get. Okay, chalo, let's come back to the previous question now. Okay, let's come back to the previous question. So now we know the Fourier transform for rect. Okay, rect of t by t. T कितना है? T का value 2 है ना already. Rect of t by 2. Having the Fourier transform 2 sampling omega. Okay, and now I need to differentiate. So let me write it as 2 sine omega by omega. Okay, so now when t is multiplied to it, t rect t by 2. Okay, that will become yt. That will become the signal yt. So that should have the Fourier transform j into d by d omega of x omega. Okay, so please simplify it. Numerator by denominator का differentiation है 2 right side 2j. Okay, denominator squared up, then denominator omega constant, sine omega differentiation cos omega minus, okay, minus omega constant sine omega, sorry, yeah, minus sine omega constant, differentiation of omega will be 1. So this is the answer. 2j cos omega by omega, you cancel this once, and minus sine omega by omega square. Option number B. Okay, 2j cos omega by omega. Okay, एक omega cancel हुआ, and with sin omega it is omega square in division. Option number B, perfectly. Yeah, it is option number B. Correct है, totally correct. Okay. Yeah, that also could be done gate 24. Yeah, can be done. Okay, if it is option based. For NAT, sometimes, you know, with rect NAT questions can also be there. Okay. Chalo. So now, as I told you, one more question. This is going to be homework for you. It is again based on the rect signal. It is again based on the rect signal. Okay. Next, consider the signal xt given to you now. Consider the signal xt given to you. Xt equal to 2 minus 2 less than between minus 2 से 2. So what is the signal xt first of all? Okay, it is twice of rectangle. When I say rect, it is amplitude 1, here amplitude 2. So I'll write 2 rect. T by the total width is 4, the rect of t by 4. Total width 4 है, so I'll write down rect of t by 4. I'll write down rect of t by 4. Okay. Now if g omega represents the Fourier transform of gt, where g omega is x omega sine omega, find the value of modulus of g2. Find the value of the modulus of g2. The g omega is x omega sine omega. X omega sine omega. What is g omega? Okay, this one is property based again. Okay, this not more on rect, this is more on property only. G omega is x omega sine omega. Dear, sine omega is written as sine theta e power j theta minus e power minus j theta divided by 2j. So in that terms, if you expand g omega, na, let us separate the 1 upon 2j outside, and then you have breaking x omega e power j omega minus of x omega e power minus j omega. Now there is an exponential term in the frequency domain, phase term in the frequency domain. So it should be time shifting. So when you want to calculate gt in time domain, you will have the time shifting x of t plus 1 e power plus j omega minus x of t minus 1. Okay. Now what they are asking? They are asking what is the modulus of g2? NAT question. Okay. What is the modulus of g2? Okay. यहाँ पहले सिर्फ g2 निकालने एक बार, then we'll do the modulus part and all. What is the g2? That is 1 upon 2j. Okay. Now x of 3, अगर t बराबर थ्रू रखा तो x of 3 minus x of 1. Okay. Now what is x of 3? The signal at 3 doesn't exist. The signal at 1 will be the constant 2. Okay, so this is equal to 1 upon 2j, x of 3 is 0 and x of 1 is actually 2. Any value of time between minus 2 se 2, the signal is 2, otherwise it is 0. Okay, the 1 is outside, 1 is inside. Okay. Minus x2 q, xt plus 1. Now I am putting t equal to 2 there. So x2 plus 1 and x2 minus 1. ठीक है जी? ठीक है. So this is minus 2 by 2j, minus minus cancel, sorry 2 to cancel, minus 1 by j, and 1 upon j is also minus j, so it can be written as plus j then. Okay. Now they are asking what is modulus. What is modulus of j2? What is the modulus of j? Is 1. Answer is 1. Numerical answer type, answer is 1. Again, property based, decent question. Okay, property based, decent question. Done hai ji? Ready for the next question. For the signal shown in the figure, okay, find x naught, okay, application based, and integral x omega d omega. Find x naught and integral x omega d omega. Now what is x naught? Dear, what is this parameter? Capital X0. That is known as the area of xt. So xt is given, we can calculate the area. And what is integral x omega d omega? Area of x omega. That is given by 2 pi x0. 2 pi x0. So these are areas property. Okay, so 2 pi x0 तो answer आ गया. 2 pi x0. xt is given. What is its value at origin? What is its value at origin? That is 2 units. Okay, so 2 pi into 2. Second answer is closed, 4 pi. For the first answer, you have to calculate the area of xt. Okay, calculate the area of xt. Acha, to calculate area of xt, okay, you may approach it. Okay, how you may approach? Okay, bhai, pehle area of this portion, then trapezium, then again trapezium, then a rectangle. But let's make it more simple, na? Suppose there is just a depression here. There is just one cavity here. Suppose if it was flat. Suppose that it was flat. Then overall it is a rectangle. Okay, overall it is a rectangle. What is the area of rectangle? Okay, height into base. Height is 2 unit and base will become minus 1 to 3. Base will be 4 unit if there was no depression. Okay, but then if there is a depression, so this area will be gone. Okay, subtract this area and this is a triangle. Okay, if you separate out this portion, na, ye kya hua? This is a triangle. Okay, area of triangle to be subtracted, half into base. What is the base of the triangle? Okay, ye 0 se 2 hai, I think, yeah. This is 0 se 2. The picture is not very clear. It is 0 se 2. Base, please take it as 2. I'll redraw it. And height of this triangular portion, 2 se 1, that is 1. Okay, so this is 1 and 8 minus 1, answer is 7. For the first part, answer is 7 dear. For the first part, answer is 7. Done hai? Chalo. This part is 2. हाँ ठीक है, सही तो बना हुआ है, correct है. It is correct only. This is 1, this point is 2. Correct. So first is 7, second is 4 pi. First one 7, second one answer 4 pi. ठीक है. चलो done. Yes, correct. Ankit Kumar, Meghna. ठीक है. Yeah, gate 24. Please let me know the doubt exact, so that I can help you accordingly for the last question. Okay, moving ahead to the next. Yes. So before I take up the next question, dear, before I take up the next question, have a look into it. Okay. Have a look into it. Okay. So, you know, BYJU'S Exam Prep has brought to you on the BYJU'S Exam Prep app, All India Open Mega Mock Challenge. Okay. All India Open. When I say open, okay, they are free for all students. Okay, they are free for all students, and the next mega mock challenge is coming up from 16 December to 22. Initially, the tests were mixed subject test, but now from 16th of December, you are going to have the full GATE syllabus. You are going to have the full GATE official syllabus, complete 65 question, 100 marks, and for 3 hours. Okay, so you can get the real exam time feel, and lots of students are appearing. Okay, so you can, you know, also check your performance among the thousands of students participating in the test, and also if you perform good in the test. Okay, so like for this MMC, that is still 22nd, result will be on 23rd December, and if you really perform good, you can also get multiple benefits in the BYJU'S complete test series. Okay, and in the test series, you can enjoy many more mock tests, subject tests, topic tests, and etc. ठीक है जी, चलते हैं नेक्स्ट क्वेश्चन की तरफ. Yeah. Intentionally taking a GATE question. Okay, it's a good question. Let's see how these varieties come up. Lakshmi Priya Rajesh, second part is just, okay, if I want to go to the second part, please say the doubt once again, but if I want to go to the second part, that is just the property, na, 2 pi x0. And what is this x0? The value of the signal at origin, that is equal to 2. That is equal to 2, okay. Area under x omega, area under the Fourier transform. This formula is obtained by the inverse Fourier transform. Inverse Fourier transform. Okay, let's take this now, guys. Let's take this. A continuous time signal. Okay, a continuous time signal. Xt is 4 cos 200 pi t plus 8 cos 400 pi t, where t is in seconds. If the input to this LTI filter with the impulse response, okay, this signal xt is the input to the LTI filter with the impulse response. Now, what does this impulse response is describing? Okay, let yt be the output of the filter. What is the maximum value of modulus of yt? Thank you, Mukul. Dekho, what is this filter describing? They have called it as a filter. What type of filter it is? Nahi, convolution se jaoge, it will be lengthy. If you go by convolution, it's going to be lengthy. Okay, what is the output of this filter? How, Ashwani? Chalo. Now, dekho, what is this ht? 2 sine 300 pi t upon pi t. First of all, let me write it as sine 300 pi t. I want to write it in the sampling function, but sampling function is sine theta by theta. Okay, by theta, but here it is only pi t, so let me multiply by 300 in the denominator, so I have to also multiply in the numerator. I have to also multiply in the numerator. So ये कितना हो गया? Okay, now this is sine theta by theta, and 2 into 300 becomes 600. This is 600. Now sine theta by theta is sampling theta. Okay, sampling 300 pi t. Okay, this is 600 sampling 300 pi t. 600 sampling 300 pi t. Okay. Of course, the second part which is mentioned, okay, is not required. They have mentioned for clarity because we know what is the value of sampling at origin. Okay, at origin sampling 0 is 0 because it is the case of sine 0 by 0. Limit theta tending to 0, sine theta by theta is 1. Okay, so automatically 600 into 1 will be 600. Okay, so they have mentioned for clarity, but that's okay even if they don't mention. So let's look into the impulse response actually. ht that is given to you, dear, is 600 sampling function. Okay, what is sampling? 300 pi t. Okay, so first of all, let us recall what is the Fourier transform. Let us first of all recall what is the Fourier transform for sampling at. For rect it is sampling, for sampling it is rect. Okay, so what is the Fourier transform for sampling? Okay, pi by a, as the formula we discussed already, pi by a rect of omega by 2a. It will be the pi by a rect of omega by 2a. Okay, so for this given impulse response, what is the frequency response of the system, h omega? That is going to be, 600 is anyways a constant. Okay, then you have sampling 80. So pi by 300 pi. A ka value 300 pi hai. Into rect of omega by 2a. So 2a karenge to you get 600 pi. Okay, so now pi to pi cancel. 600 by 300 will be equal to 2, and this is of the form 2 rect omega by 600 pi. 2 rect omega by 600 pi. Okay, and that had 2 also. I multiplied 2 into C 600. Correct. Okay, so pi by a rect of omega by 2a. Okay, this is the h omega. So if I want to draw this h omega, if I want to plot the h omega, dear, if I want to plot this h omega, how it is going to appear? If I want to plot the h omega, it is 2 rect omega by 600 pi, rectangular function in the frequency domain. It's a rectangular function in the frequency domain. Okay, and having the total duration 600 pi. Total duration 600 pi. Okay, so minus 300 say plus 300. Okay, the constant rectangular value, the value will be 2, and this will be minus 300 pi. This will be plus 300 pi. Okay. Now, what is this actually? This type of characteristic is showing you that if there is any frequency, now you send the input of any frequency up to 300 pi, it will be passed, okay, with the gain 2. But if you send any input to the system having the frequency component greater than 300 pi, okay, it will be passed with 0 gain. So 0 into anything will be 0. It is going to block that particular frequency, and this is the, everybody must be knowing at this point of time, gate ke itna close aake, you must be knowing it, what we call it as. It is nothing but an ideal low pass filter. It is just an ideal low pass filter. It passes all the frequencies up to a particular frequency. Beyond that it rejects, and that too ideally. Ideally means up to that frequency equal gain, beyond that 0 gain. So what is that cutoff frequency? That cutoff frequency here is 300 pi radian per second. That is the ideal low pass filter. Okay. Now, if you have an ideal low pass filter and there is an input given to me, okay, 4 cos 200 pi t plus 8 cos 400 pi t, you might think, let us calculate its Fourier transform, something. No, by logic, okay, by just aptitude logic, let's try to answer this question. Okay, by aptitude logic, let's try to answer this question. So, kitna ho gaya? What is the value of xt? That is given by, okay, 4 cos 200 pi t, 4 cos 200 pi t plus 8 cos 400 pi t plus 8 cos 400 pi t. Okay, so input has two sinusoidal term. One is having the frequency 200 pi, another one is the frequency term that is having the frequency of 400 pi. Okay, now one of them is less than omega c, but another one is greater than the cutoff frequency of the filter. So when these two frequency components are going to be passed, okay, which of them will be passed actually? When this signal is going to be the input to the filter, only those frequency components which are up to 300 pi will be passed. Okay, will be passed. This is your cutoff frequency. Okay, so this one is in the pass band, this one is in the reject band, and that is rejected. Okay, so what is the output? Okay, only the first signal will be passed. And what is the gain? The gain, it is twice. Okay, it is twice of 4 cos 200 pi t. It is just passed with the gain of 2. The next one is rejected. Okay, so output corresponding to it will be 0. So the complete output is, even if they ask expression, you are in a position to say the expression 8 cos 200 pi t, and what is the maximum value of modulus yt is 8, because cos theta maxima is 1, so answer will be 8. NAT question. Band pass, when it passes a finite band of frequency, something like this. Band pass Meghna should be something like this, not starting from origin. If it passes a set of frequency from omega 1 to omega 2, then it is band pass. Okay? Then it is band pass filter. The answer is 8. Okay, answer is going to be 8. Done hai ji? Okay. So time is 10:45. I think that's it for today. Now, questions can be unlimited from Fourier transform, but yeah, different varieties of good questions. Good questions. Only one PYQ I have taken today. This one is the only PYQ that we have discussed today. Just to tell you, even some filter-based question, but that is very logical. Fourier transform related can be expected from here. Okay, rest all different property-based question we have discussed today. Okay, so Yeah, I think we can stop here 10:45 and you can practice more and more question. I hope all properties, what is one good thing that I'll tell you about today is you have got all properties, all Fourier transform pair to be remembered in one particular PDF along with lot of variety of question practice. So it will be very good for revision. And now, okay, if you're a GATE 24 aspirant and looking for a complete quick revision along with question practice for the entire syllabus, not only like special 26, but entire syllabus. So you can enroll to the Vision GATE 2024 crash course. Complete syllabus coverage with the problem practice will be there. And also guys, those who are going to prepare for 25 and 26, that is the upcoming GATE or Engineering Services examination, the complete courses for the upcoming years are also launched on the BYJU'S exam prep app in both the formats, in the English as well as the Hindi format. Okay, and all these courses will offer you live classes along with the facility of recorded lectures, study material, mock test, practice quiz, everything to get you exam ready. Any queries about this? Contact 924-133-666, be it about the timing, faculties or fees. Any queries you have, you can contact and get your doubts rectified and you can then enroll. Okay guys, so I'll share you the today's PDF. Password bata dete hain pehle. Okay, so password for today. Lot of frequency discussion, and the password for today's PDF will be frequency. Everything in small. Okay. See Samuel, to be honest, Fourier and around its application. Acha, one thing around application of Fourier questions I could not take you today. I suggest you to practice on your own because time is already, it's about to be 10:50. Okay. The password for today's PDF will be frequency. You can note down. Okay, so yeah, just one area where, I wanted to cover but I could not cover, and that is the Parseval's theorem. I've given you what Parseval's theorem is, but us pe question nahi kar paye. So there's one request. Okay. Parseval's theorem question, please practice, and if you have any doubts you can let me know in Telegram. Maybe later on we plan some sessions around it. Okay, so Parseval's theorem, please practice some questions based on that. Okay guys, so this you can be connected in my Telegram group for PDF, for the update of the classes, for update about the job vacancies and all, and very importantly to discuss your doubts, to get more concepts. So I'll just share you the link of the Telegram in case those who are not connected in the Telegram. This is the link. That's it from my side. Bye bye, thank you. So tomorrow, now in the special 26, okay, in the special 26, okay, tomorrow same time 9 PM, okay, tomorrow turn is Sanjay sir, and he is going to now bring next important topic in this special 26 series, and that is the two-port networks. Very, very important. Almost sure you get the question from two-port network, so don't miss it. Tomorrow 9 PM two-port network. I will be then coming Monday 9 PM. Okay, I will be then coming live on Monday 9 PM with the next important topic in special 26, Z transform. I hope you're all aware how important Z transforms are. Okay, the next important topic in special 26 from my side will be Z transform. Tomorrow Sanjay sir will be taking two-port networks. Okay, and yes, in case if you're preparing for ISRO, so tomorrow 11 AM there is a session for ISRO aspirants, and that is the question practice, important question on antenna, because antenna, whether it is GATE, Engineering Services, ISRO, BEL, any examination, okay, antenna is most likely to come. And in an exam like ISRO, okay, there may not be one, but in single paper you may get 2 to 3 questions only from antenna. Okay, 2 to 3 questions only from antenna. Okay, so tomorrow 11 AM there is a question practice session on antenna theory, okay, for ISRO. And of course that will help you for GATE also. If you have prepared antenna for GATE, you can join that also for the practice on antennas, question practice on antenna. Bye bye, thank you, stay safe and take care. Yes, definitely negative marking is there in GATE, but only for MCQ. 1/3 for 1 mark, 2/3 for 2 mark. Okay. But for NAT and MSQ question, there is no negative marking. Bye bye, good night, stay safe and take care of yourself, dear.